Hello, I'm Jarasula, a student from the Technical University of Catalonia, and in this video I will show how to use the SPI port implementation according to the MicroFramework. First, it will be run on a MicroFramework-enabled device, then using my custom implementation of this framework on a Linux device. These are the devices that I will use to show how I'm using my current port of MicroFramework from Microsoft. This is an Arduino Plus, which uses MicroFramework as its own runtime. As you can see, it has an Arduino layout socket. Now I'm showing my test device, which consists of a Raspberry Pi, the Model B. It runs Linux, so I will use Mono to run my example code using my port of MicroFramework. As I'm trying the SPI port implementation, I will use this RFID card reader, which uses SPI to communicate to the native MicroFramework device or to the Raspberry Pi device. Finally, it's time to show this shell. The shell it can be used either on a Raspberry Pi or an Arduino. In its back, it has a GPIO socket or an Arduino socket. On the front, as you can see, it has an Arduino socket and two XB sockets to connect more devices. Now, if you want more information about these devices, just take a look into the links provided in the description of this video. Now it's time to see how this implementation or this RFID reader works using MicroFramework. So in this screen you can see two solutions, one according to the Linux solution and the second one is the Arduino solution, which uses the MicroFramework natively or the MicroFramework provided by Microsoft. As you can see here in this folder you can see a SPI example and a SPI API. Both of them are used by the Linux solution and Arduino solution. First of all, I will start running the Arduino solution, and if you take a look into the little screen, I will connect this shell to the Arduino and plug in to the USB socket the Arduino. While it's starting, we will take a look into this code. Basically, here we have a new instance of a SPI API, and then we configure the SPI as the MicroFramework says using the SPI configuration, and then basically we will print out the version and get the card information out. Taking a look into the properties, you will see that it's MicroFramework in version 4.2, and well, the deployment device is an Arduino Plus. And if you take a look into the references, you will see that it's using Microsoft Spot, which consists of the classes for the MicroFramework devices. Now I will start running. While it's going on, you will see this output screen. I will use two different RFID tags. This is a card and this is the tag. As you can see, now it has detected correctly the version, and I will try to detect this card. As you can see now, the card has been detected, and now it's the tag time. Now this is working. So it's time to close the Arduino version of this solution and test how it runs in the Raspberry Pi or what will be in a Linux environment. Now it's time to start testing the MicroFramework port to the Raspberry Pi or to the Linux. First of all, I will swap the Arduino to the Raspberry Pi. As you can see in the camera, I just plug out the Arduino, plug in the Raspberry Pi to the GPIO socket. It's quite difficult without seeing at all, but okay, this is well connected. This has been disconnected. Now I will unplug for safety the RFID reader, and I will power on the Raspberry Pi because it must be powered on to test and deploy my example. While it's going on, I will start the Linux solution and I will explain in what it consists of. In this case, as you can see on the left on the solution, we have the Linux version and I have added the Microsoft.Spot version, which implements the native MicroFramework but at software level. For example, the SPI, I use basically the Pinebox to call the internal write or internal read functions. Okay, so for example, if you take a look at the code, the SPI example, it's the same. I instantiate the object, then I configure the SPI using the same way, and then just print the version and start getting the camera. As I'm using a Samba deployment, now I will compile once the Raspberry Pi has been connected. Okay, and now I will open the PuTTY and connect to the Raspberry Pi. Okay, I'm in. Going to superpowers. Okay, I feel that. And going to the TFC folder, clean it, and as you can see, it's totally empty. So now I will compile it, build success, and now taking a look into the project. Okay, we have the Linux version, so write mono Linux, and before connecting or executing that, let me connect first the device. Start running. Okay, version detected, and now using the same card, it has been detected. And where is the tag? Here is the tag, and as you can see, it is working as it was working the MicroFramework on the Arduino. And well, that's all. I hope you have enjoyed, and if you want to test, just go to the GitHub account and fork it or download it. Many thanks, and see you on the next video.